Okay, this is a continuation in videos for homework problems 2.3. So we're looking at problems 1 through 12 and each determine whether the function f is continuous at the given value of a. If it is not, decide whether or not the function is continuous on the left or the right. State the reasons for each step in the argument. So here we have a function that is similar to problems 3, 4, and 5, where the annotation is a little different, where we have the function f tends, where x tends towards 1 over x is our limit as x approaches, as a approaches 0. So from here, we're going to check on our limit. So again, our limit as x approaches a for 1 over x, for our function rather. Our function is equal to the limit. So we're going to have here our limit as x approaches 0, a is 0, for our functions 1 over x. Well, as we see here, we can't have, it's undefined, right? So the limit does not exist. Okay, so we look to see if we can establish a limit from the left or the right. So the limit as x approaches 0 from the left for 1 over x. Well, if you're looking at negative numbers, right, like negative 1/2, that'll be negative 2, or 1 over negative 1/3, that'll be negative 3, and so on. So it's going to go further and further and further towards negative infinity. So there's no limit there. And so as x approaches 0 from the right for 1 over x, you're going to get positive numbers. So that'll be like 1. So you're looking at your function basically is a reciprocal graph. So as x approaches 0, as a approaches 0 from the right, then you're going to get, 1/2, which will be 2, or 1 over 1/3, which will be 3, and it keeps getting larger and larger and larger. So that's going to tend towards infinity in the positive direction. So again, there's no limit there too. So therefore, we can say that there's no endpoint for a from the as x tends towards a from the right, nor as x tends towards a from the left. So there is no limit from the right nor the left, since there is no endpoint in the interval. Therefore, there is not continuous from at x equal a, nor as x approaches a from the right, nor as x approaches a from the left. So it is not continuous at A, not continuous from the right nor the left, so is not continuous for any scenario. And that's the end of this video.